First step in creation of any robot is construction. Mechanical engineering plays important role in construction of a robot. Various motions required in a robot are achieved by using different mechanical components. In this session, we will be understanding these mechanical components and their usage, which will empower us to get required motion.
Let's look at the learning objectives of this video. We'll first understand types of gears, then we'll look at the usage of gears, then we'll look at the pulley and its usage. We'll understand the working principle of a lever, we'll see the types of levers, and finally the usage of levers.
Let's now look at mechanical components that will be extensively used during construction of a robot. Can you name one mechanical components each? Okay, then here is the list of mechanical components: gear, pulley, lever, wheel, bearing, metal parts, axle and axle locks, and lastly, nuts and bolts. In today's session, we will focus on gear, pulley and lever. We will learn how to construct various motions using these three components. Gear is the most important and extensively used mechanical part. It is defined as a rotating machine part having cut teeth or cogs which mesh with another toothed part in order to transmit torque. From the definition itself, it is evident that gear is mainly used to transmit torque or transmit rotatory movement. Gears come in different types, each aimed at achieving a particular motion. Let's see some examples. Regular gear. This is a circular gear which can mesh with all other types of gears except for the bevel gear. Linear gear. As the name suggests, this is linear in shape and can be meshed with all other types of gears except another linear gear or the bevel gear. Spiral gear. Also known as worm gear, it is just like a screw. Bevel gear. This can be meshed with another bevel gear only and transmits motion from one plane to another, usually at 90 degrees. As the definition suggests, the main purpose of gear is to transmit motion from motor to other robot assemblies such as wheel, arm, etc. You must have seen a bicycle. It has pedal attached to a gear-like structure. The same is then attached to another gear at the center of rear wheel by using a chain. This gear is then attached to the wheel. This structure helps to transmit the rotatory motion created by the legs to the rear wheel and the bicycle moves. In addition to this, gear can also be used for a few other purposes. Let's understand each of these in detail. Pay your highest attention as this is going to be required every time you think of making a new robot. Let's do a small experiment. Take two gears from your kit, one big and the other one smaller. Mesh them and rotate the big gear using a shaft. Count the number of rotations of the smaller gear when the big gear is rotated once. What do you see? The smaller gear rotates more than once during the single rotation of the big gear, which means that if we attach the big gear to motor or the source of motion and the small gear to the assembly or the part we wish to rotate, then the assembly will rotate faster than the motor speed. If we exchange the gear positions, then the assembly will rotate slower. So now we understand that the gears can be used to increase or reduce the speed at which the assembly can be rotated without changing the motor speed. For increasing the speed, attach the big gear to motor and small to assembly, and for slowing down, attach small gear to motor and big to assembly. The increase or reduction in speed is directly proportional to the ratio of the gear teeth. Let's consider an arrangement shown on the screen. The yellow gear is connected to a source of power. The red gear is meshed with yellow gear and is free to move. A blue shaft is connected to the red gear. Watch the movement of the blue shaft. The far end of the blue shaft is moving up and down. That is in linear fashion. So the circular movement is converted into a linear motion. Now see that the center of the red gear is revolving around the yellow gear center. This is concentric movement. When we mesh two gears, they rotate in opposite directions. If we mesh three gears in series, then the first gear and the third gear will rotate in same direction, while the second gear will rotate in opposite direction. Thus all even gears will rotate in one direction, whereas all odd gears will rotate in opposite direction. Bevel gears are used to transmit motion 90 degrees to the source of rotation. A combination of bevel gears, circular gears and a differential drum is used to get a differential motion or angular motion, which is used extensively in cars. Let's now understand about pulley and how we can make use of pulley in robotics. A pulley is a fixed or movable grooved wheel. We have been using pulley to fetch water from wells for many years. Same is with this equipment used to get butter from the curd. The latest addition is the clothes dryer system used in flats to save space. In these examples, pulley is used for different purposes. In the butter making example, the linear motion is converted into a circular movement. In the well and clothes dryer example, we are changing the direction of movement. Pulley has another important usage. When we use one pulley, the pulling effort felt is same as actual effort and the displacement of the load is same as the distance pulled. Now let's add one movable pulley. Now to displace the load by x units, we will need to pull the cord by 2x units, which is double the displacement. But at the same time, the effort needed is reduced by 2 times. This means the efforts needed is halved. As we add more pulleys, the required displacement increases, but the effort needed is reduced. Lever is not a component but is a concept. Many parts can be used as lever. Let's assume that M1 load is placed on one side of the lever and M2 load is kept on the other side. Now to balance the load over the lever, the fulcrum point needs to be placed such that the product of the load and the distance between load and fulcrum point is equal on both the sides. Through this example, we can see that even a lighter load can balance heavier load if we manage their distances from the fulcrum point. If the lighter load is the effort, then we can lift heavier load with little effort by adjusting the distance of load and effort from the fulcrum point. Levers are divided into 3 types such as class 1, class 2 and class 3 lever based on the relative position of effort, load and the fulcrum point. Some examples of levers used to reduce the effort are rowing oars, a wheelbarrow, a crowbar and a nutcracker. Movement of the fulcrum point can also result into less or more displacement. If fulcrum point is close to the point of force, the displacement is more compared to when it is away from the point of force. The amount of amplification or reduction is dependent on the force and the distance of fulcrum point from ends.
So in this video, we saw the types of gears, we saw the usage of gears, then we understood what is a pulley and usage of pulley. We then looked at the working principle of a lever. We understood that lever is not a component but it is a concept. Then we looked at the different types of levers and usage of levers. This brings us to the end of this video. In the next video, we'll perform an experiment with lever and understand it practically.